Welcome to The Explainer. Today, we are diving deep and looking under the hood at one of the most transformative technologies out there, generative AI. We're going to break down the core blueprints that allow these incredible machines not just to learn, but to actually create. You know, for years, AI was really good at finding patterns and making predictions. It was all about analyzing what already existed. But now, a totally new wave is here. So what if AI could go beyond just analyzing and start generating entirely new things from scratch?
And that, right there, is the crucial difference. Unlike older AI, generative AI makes stuff. This is a massive leap, right? We're moving from AI being a super smart analyst to being a creative partner, learning from tons of data and then creating something brand new. Okay, so let's get into the nuts and bolts of it. To really get how this all works, we need to look at the four main blueprints, the architectures that power these creative machines. Each one has a totally unique way of doing things.
First up, we've got Variational Autoencoders, or VAEs for short. Now, these models are absolutely brilliant at learning the essence of something. Think about the general idea of a chair, and then using that core concept to dream up brand new chairs. So here's how it works. First, an encoder acts like a summarizer. It squishes, say, an image down into just its most important features. This compressed info then lives in a cool place called the latent space. Finally, a decoder grabs that compressed essence and reconstructs a totally new, original output from it. It's kind of like summarizing a book into a few key plot points and then writing a whole new story based only on those points.
And you see this out in the real world, especially in fields like fashion. Designers can use VAEs to dream up new styles. You train it on thousands of pictures of dresses, and it can start generating unique designs that fit the overall style but have never actually been seen before.
Next up, let's talk about Generative Adversarial Networks, or GANs, and the name really says it all, adversarial. These things learn through a fascinating and really competitive game between two neural networks that are constantly trying to outsmart each other.
Just imagine an art forger and a detective. One network, the generator, is the forger. Its job is to create a fake that looks real. The other network, the discriminator, is the detective trying to spot the forgery. Every time the detective spots a fake, the forger has to get better. This game goes back and forth, pushing the forger to create fakes so convincing that the detective just can't tell the difference anymore.
And the result of this constant competition? Some of the most stunningly realistic images we've ever seen from an AI. The classic example is Nvidia's StyleGAN. You've probably seen its work. It creates these incredibly photorealistic portraits of people who are completely fictional. They've never existed.
Okay, our third architecture takes a completely different road. Autoregressive models don't just create the whole thing in one go. Instead, they build things up sequentially, one single piece at a time. It's a lot like how we speak or write, right? Each word you choose in a sentence depends on the words that came just before it. It's a step-by-step process. This makes these models absolutely perfect for anything that needs to have a logical flow, like generating a paragraph of text or composing a piece of music.
And that sequential nature is what makes them so effective. It allows for really structured and coherent output. A fantastic real-world example is WaveNet. It generates incredibly natural-sounding human speech by, you guessed it, predicting the very next audio waveform based on the one that just happened.
And that brings us to our fourth and final architecture, and this is the big one. This is the model that has really come to dominate modern AI, especially when we're talking about language, the transformer.
So transformers are a total game changer. Unlike the step-by-step approach of autoregressive models, a transformer looks at the entire sentence or even a whole document all at once. Its secret weapon is something called the attention mechanism. This lets it figure out which words are most important and how they relate to all the other words, even if they're far apart. And that's its superpower. It's why they're so good at understanding deep context and nuance.
It probably comes as no surprise, then, that transformers are the engines behind the incredibly powerful language models we're all using today. We're talking about things like OpenAI's GPT series and Google's Gemini. They're powering everything from advanced language translation to those sophisticated chatbots.
So, let's do a super quick recap. We've got VAEs, the artists that compress and reconstruct. We've got GANs, the competitors that fight it out for realism. Then we have autoregressive models, the storytellers that build things piece by piece. And finally, transformers, the big picture thinkers that understand context like nothing else. Okay, so besides the architecture, there's another really key distinction here. How many senses or types of data can an AI work with at the same time?
On one hand, you have unimodal AI. Think of these as the specialists. They're really good at one thing, like text in, text out. But on the other hand, you have multimodal AI, and these are the generalists. They can connect different kinds of data, like turning your text description into a stunning image, which is exactly what models like DALL-E do. They're bridging the gap between our senses.
So that's all the theory. But what's really exciting is seeing how all these powerful tools are actually being used out in the real world right now.
And the short answer is, well, everywhere. It's making huge waves across so many industries, whether we're talking about content creation, fashion, media, or even just day-to-day business communication.
And what's so cool is you can draw a straight line from each architecture to these real-world uses. Of course, VAEs and GANs are perfect for dreaming up new fashion designs. It just makes sense that autoregressive models are powering realistic voice synthesis. Transformers are running chatbots in businesses, and multimodal models are opening up entirely new worlds for artists.
So after all that, what does this really mean for us? Let's zoom out and think about the big picture here, especially when it comes to something as human as creativity.
You know, if there's one key thing to take away from all of this, it's that these models aren't really about replacing us. They're becoming powerful partners, amazing tools that can augment and extend our own imagination, helping us explore ideas and create things in ways that were never even possible before.
But all of this leaves us with a really fascinating and kind of tricky question for the future. As these models get better and better at what they do, is it real creativity? Or is it just an incredibly clever recombination of everything they've learned? It really starts to blur the lines of what it truly means to create for a human or a machine.